Are we good? Oh, we are good. Okay, hi. So welcome this afternoon. My name is David Ward. I'm the CEO and founder of a company called TELEGRAPH Software, which is located here in San Francisco. We provide outsourced software product development services, largely to the software as a service companies located here in the Bay Area. And I want to thank Neo Technologies for inviting us to talk today. And what I'm going to talk about is a bit of a journey over the last 15 years, but the last 4 years in particular with one of our premier clients, a company called Lending Club here in San Francisco, the premier loan marketplace, peer-to-peer lending company in the world at this point. A couple things that might help me with the talk. So one thing is everybody in the audience who's a hands-on technologist, can you raise your hand? Okay. Well, one bit of warning on this. Most of this talk is probably going to be from the perspective of your manager. It has more to do with the scale, cost, and personnel issues around cloud management than it does the specific technologies. But I'll try to mix in as much geeky stuff as I still remember. So as I said, this is something of a walk down memory lane for me. What I have here is the Wikipedia page for NoSQL, and it's something I visit a lot because it seems like every couple of weeks there's a new NoSQL project and database that's invented. My experience with NoSQL actually begins back in the mid-90s with a company called Arbor Software, which invented a database called Essbase. Essbase is arguably the highest revenue-producing NoSQL database in the world. It's over a $1 billion a year line of business for Oracle at this point. It's an OLAP database. It was designed for rapid financial analysis of multidimensional data. So it's been very interesting to me to see in the last 10 years in particular this renaissance of invention of NoSQL databases around open source projects. It's given all of us in technology a set of tools that didn't make cost-effective sense 20 years ago, but it very much makes sense now. So what's enabled that in particular? One is very cheap and ubiquitous network and computing power. 20, 30 years ago, the cost of both the capital equipment as well as the software was such that we were pretty much forced economically to funnel as much of our software work through as few products as possible. So generally speaking, that meant a relational database. It was the most general purpose repository available to us. Essbase, in fact, was only as successful as it was because it was able to take advantage of the power of personal computers to display the multi-dimensional data in near real time. If it had all been host-based, probably wouldn't have worked. But certainly what's happened now is you have plenty of computing power, you have plenty of network ubiquity, and you have open source, which means we had a set of components to pick for particular solutions that just wasn't possible at any other time in the history of computing. And Neo4j, of course, is part of that trend. So another part of the journey has to do with IT management. I've been involved with IT management software for over 30 years now. And what I'm showing here is a representation of the ITIL framework. It stands for IT Infrastructure Library. It's one of the popular frameworks for describing the entirety of the software that's used to manage IT infrastructure. As you can see, there's many different components to it, and if you went about trying to implement this all at once, it would cost you many, many millions of dollars and many multiple vendors in order to put it in place. But you could say it's an example of sort of big IT, where you have a big problem, so you spend a huge amount of capital, for a big solution. However, it is based on some very long-established and effective best practices. And one of those is come to be called a configuration management database. It's extremely valuable in any context of IT software, of IT management software, to have a repository of everything that exists in your IT network and environment, both hardware and software. And as it turns out, my company and my colleagues have experience with implementing these CMDBs, necessarily in big corporations, because they're really the ones that could, effectively afford it. So the next thing, I'm going to borrow an idea from Stallman, Richard Stallman, in his book, The Cathedral and the Bazaar. And that's the notion of, there's two different approaches to software development. One would be the cathedral approach, by which, not to put words in his mouth, but a top-down approach, a command and control approach. There's a master architect, there's sort of a strong set of controls over the implementation of IT or software. And that produces this big integrated edifice. Ideally, it's as beautiful as Notre Dame, although oftentimes it turns out to be not nearly so beautiful. So we asked ourselves, after working in big IT for big corporations at the start of the cloud era, would you do it this way again? Now that computing is so inexpensive and open source is so prevalent. And another trend, which I think plays to what we're going to talk today, the need for rapid software development. I think we've all heard the term from Andreessen that software is eating the world, and it's very, very true. There is unceasing demand for new software of all sorts, all the time these days. But if you didn't choose the cathedral approach, what's the bizarre approach in this case? Well, I think it goes back to that first slide of all those open source projects. What you have now is people all around the globe, working all the time, inventing new tools, new components, new databases, and then bringing them up to enterprise standards. And this was a very real trend when we started working on this, 6 years ago. And the approach that we wanted to take, to cloud management was to take advantage of that open source, because it enables, much smaller companies and many more startups to get the same benefits. So as I just said, we wanted to enable a lot of these benefits for startup companies. So startup companies obviously aren't going to have the millions of dollars for building a cathedral. So how can you do enterprise scale DevOps at 90% off? Because that's the kind of economics that we're looking to be constrained by. So one of the things we did was, how could we combine an integration architecture? If you're going to compose your IT management suite out of all these open source components, then you're going to be doing a lot of integration work, between those components. So what would be, the best architecture pattern, to use for that. So the answer, we believe, is an integration hub. And this, harkens back to the CMDB I was talking about, the cathedral approach. It is a best practice. It's extremely important to have a real-time repository of what's deployed in your network, both hardware and software. We wanted to do it cheap. We wanted to do it fast. And we knew that we would have to evolve the services over time. A startup, typically starts with a set of base requirements, usually around continuous integration, rapid deployment. In other words, getting all that new software out as rapidly as possible in a controlled fashion. But then all those other components of big IT management enter into that company over time as your security requirements increase, perhaps compliance requirements, any number of things. And hopefully you're big enough where planning and sizing and cost control are important as well. So just to give credit where credit is due, most of the ideas I'm going to be talking about today come from a colleague of ours named Rob Shaning, who currently heads up DevOps at Lending Club. And he was a fan of this old TV show called MacGyver. I don't know if anybody has seen it, but the character was famous for being able to cobble together extraordinarily sophisticated solutions out of household articles, a particular favorite being duct tape. So the project that we started is called MacGyver. You can find it in GitHub, and I hope you will look for it there. And when we thought about that real-time repository that we wanted to create, we actually went on a bit of a journey with that as well. At first, we started with a relational database with MySQL. But a relational database is not an ideal data structure for representing networks. And let's face it, what we deploy out into cloud environments or virtual environments or physical environments is a network of hardware and software, and knowing the dependencies between those. The relational database is particularly bad at shared components, such as network nodes or control points in your IT infrastructure. It's hard to query, and it's hard to visualize. So the next thing we experimented with was Mongo, a key value open source database, and that was a little bit more usable, but still not ideal. When we started working with Neo4j, though, we found just a natural congruence between the data structure and the objects that we knew we were going to be operating on. Now these are the set of basic services that make up the MacGyver framework. It's an integration hub, so having APIs, both event-driven and polling, is very important. To many different sources of information about your infrastructure. And I'll get to some of those integration points in a little bit. But a key part of the framework is a very lightweight and flexible scheduling engine based on Quartz, as well as event response software using the Spring framework. You can see the other components there. It is entirely built on Java. We don't deal with non-Java execution environments. So actually some of the scripts and displays that we've done are developed in Ruby, but we use Grails so that it runs on the engine. An extensible UI, we think that visualization of infrastructure is extremely important for anybody operating with it, both on the development side as well as IT operations. And we developed a sophisticated set of tools for sort of higher function use cases, which I'll get to in a bit. And of course, the implementation needs to be high availability and multi-site. So once again, to sort of emphasize, Neo4j really turned out to be perfect. You've got a data structure which is congruent with the objects being modeled and represented. You have an excellent ad hoc query capability. The scheme itself is easy to extend. We believe, which meant that we could start with basic sets of virtual components and then extend it to more sophisticated and more detailed areas over time. Very easy to consume, particularly in the object packages we built, for non-IT users to take advantage of. JSON native, really just the perfect solution. And it would have been so much more difficult to have to force fit, this into a relational structure. So here's a quick, representation of a kind of network relationship, the kind of query that you might want to ask out of the repository, and with an example of a cipher query shown below there. So over the last 4 years, we've grown to the following use cases, IT management use cases at Lending Club. The first one, and the most primary one, really, has been continuous integration and automated deployment. One of the problems in the area of never ceasing demand for software is it's very hard for IT operations to stay in front of development. If you work in IT operations, you're typically always dealing with development people who are impatient with you because you're slowing them down. So the first use case, that was implemented in conjunction with Jenkins was continuous integration and automated deployment. Beginning with applications, but then extending out into provisioning systems themselves, using Puppet or Salt, product like that, and then out into entire environments. Test automation, not just provisioning and pushing out, new applications, environment systems, whatever, but also invoking the automated testing, to make sure that what got pushed out is actually working. Release packaging, I think you can read the rest of the slides here, but a good, strong subset of what was on that original ITIL slide has now been implemented. And really without very much code. I want to emphasize again that one of our thought experiments and discoveries, and I think we've proved, is that if you have the right data representation, you're going to write a whole lot less code, and you're going to be able to adapt that over time as your business grows and gets more sophisticated. So these are the integrations, that have been performed at Lending Club. You can see that extends from the network and security components, software code and deployment, authentication and access control, cloud service, a couple of varieties of dashboards and visualizations, notification scenarios. Performance monitoring has also been a very important one. We're big fans of New Relic. You can see on the right, system configuration, products like Puppet and SaltStack. Monitoring, Splunk, and log controls. So I would also say that probably the most powerful sort of non-technical feature of the MacGyver approach at Lending Club has been this ability to evolve along with the company and its business needs. There's several important, I think, very strategic, side effects of this. So one is they were able to go from physical infrastructure to virtual infrastructure with VMware, and now, cloud native infrastructure in AWS. And every step of the way, they're able to do that in a forward fashion without jeopardizing the business, because if anything goes wrong, they can always fall back on the previous configuration, which is well known and defined in the Neo4j database. Most recently, more or less concurrent with the cloud migration, has been moving from monolithic applications to microservices. 6 years ago, we were dealing with 4 or 5, depending on how you count, sort of monolithic applications. Now we're automatically deploying something close to 350 separate services into the cloud. Although we started with Jenkins, for continuous integration, that's also evolving along with the sophisticated cloud environments. So we've had some recent success, with AWS Code Deploy, which is fine. It just means, we're dependent on, we have to manage and maintain less code. More is being done by our vendor. And again, an easy migration and enhancement route for Lending Club. And the last one I think will be has already proved itself important, is vendor independence. If you think back on the open source projects, or the previous talk for that matter, you may start out with one open source component, product, and then find a better one over time, or one gets invented over time. And the framework allows them to replace lower functioning components with higher functioning components, or go from the basic edition to the enterprise edition, like we did with Splunk. So, now I'll close a bit with some of the more sophisticated cases around microservices. Like I said, we're up over 300 services being deployed now. So, how do you keep track of those with low maintenance, scalability, and such? And then how do you deploy them? If any of you are familiar with microservice deployment, if you put out a new version of a service, you still have the old ones out there running. If you're a 7x24 operation, that can be a pretty sophisticated operational scenario. So I'm going to show you some slides about how that's been automated, because it's not something you'd actually want to do manually. So you've got pools of service out there. And again, these are screenshots taken directly from the graph interface onto the Neo4j database that we use. We're really talking about blue-green deployment of microservices into different pools across multiple sites. You've got the existing live pool in green. You've got the dark pool on the right. You deploy into the dark pool. And now you wait for the original pool to drain and those services to die off, and then start to route functionality over to the new live pool until you're completely transitioned over. So this is an example of a very sophisticated deployment scenario that we've been able to automate and enabled by the framework. And then you end up with these virtual services deployed, and again, these are the kinds of displays that you can query the database with and see what's going on. All right, so maybe 300 was a high estimate. I've got 280 here on this slide, but that's still a lot. And the number is increasing every day and expected to increase indefinitely, both as Lending Club's business sophistication grows and the scale of their technical operation grows. Over 4,000 hosts and 500 currently AWS instances, 2 sites, 4 environments, close to 110,000 graph nodes. And just out of curiosity, we wanted to test whether we really did come up with an approach that was more efficient than other people. So we looked at the Netflix open source operational libraries. And we think we've done similar functionality, for less than 10% of the code lines. DevOps code is code like all other code. It costs money. You got to maintain it. You have to have programmers familiar with it. If you can write fewer lines of code, it's going to cost you less. Here's just some other views, just to give you some idea of what the users experience. That's an AWS code deploy scenario. All right, and the last one is what's coming up next? Well, what's coming up next are some very sophisticated use cases that depend on this enriched data in the Neo4j database in order to implement. So one I'll talk about briefly would be that we're getting to the point now where we can deploy code and actually know, and this is a company with 200 programmers working for it, and be able to say in the deployed code whose code might be causing a performance problem in the production instance. That's only possible because we have this network database that associates so much data, so many metadata attributes about what's deployed. And we can start to leverage these tools in ways that wasn't ever possible before. It also, in the future, brings up the potential for automated or machine learning scenarios. IBM's written about this quite a bit as well. So it's interesting 4 years on to be on the edge of those kinds of scenarios ourselves. So finally, a few closing thoughts. MacGyver is really an integration architecture. It's an approach. It's not for everybody. Not all companies have to release software as rapidly as our clients do. A lot of companies have more money and more capital to deploy than our customers typically do. But what we found is that for the startups in this area, and the ones that would prefer to build on open source stacks, this is an ideal approach. And I think the big surprise from a business point of view has been the evolvability of this framework. The ability to keep upgrading the components that you use to manage your system, to move from physical to virtual to cloud native in a way that doesn't affect the running of your business. And it's also done very cheaply, very inexpensively, compared to buying big IT tools or employing dozens of developers. So that's it for the talk. If you have specific technical questions, as I mentioned, one of the engineers on Rob Shaning's team, Ashley Sun, is attending Graph Connect, and she's with us today. You can also contact myself. This is a public GitHub project. You can take a look at yourself and look at the materials out there. So hopefully we get us back on schedule, but I'm happy to take any questions. Okay. Well, thanks very much.
Thank you.